This is Unit 6, Lesson 2, and so far we have done the combining, adding and subtracting of monomials. They have to have like terms. And then we've also done multiplication with monomials, and with multiplication we learned that when we multiply with exponents, we add them together. So when we multiply with, we add. So you're probably already thinking, gee, I bet when we divide we're going to subtract, but we're not there yet. So what we're looking at today is powers of monomials. So when we have a monomial like this inside of the protected little parentheses, and it's being raised to the power of 2, that's what that's called, raised to the power of 2. So here is the rule. It is to raise the coefficient, if there's a coefficient, and I'll show that in the examples we're going to do. And then it says use the power rule to simplify the exponents. So with the power rule looks something like this. That means I'm going to multiply that n times that m. So we would have a, and it would be m times n, which in the long run would be amn, and that would be our answer for this one. So on this one up here, since I got this nice little example, we might as well do this. So I'm going to raise that 4 to the power of 2, and I'm going to raise this 3 to the power of 2, and when we raise to the power, we multiply. So that 4 is to the power of 2, so it would look like this, because there's actually a 1 here, so 1 times 2 is 2, and the x would be to the 6th power. Now, it's not simplified all the way, because 4 times 4 is 16, so if we were to simplify this all the way, we would have 16x to the 6th as our final answer for being raised to the power of 2. Okay, so we're going to do that with numbers with these next few problems, and I'm going to enlarge it so that it's nice and big. And here we have this x squared being raised to the power of 5, so we end up with x to the 10th as our answer, because 2 times 5 is 10. Here we're going to raise this c, which is actually to the power of 1. So I put a little baby 1 in there, so 3 times 1 is c cubed. 3 times 2 is d to the 6th, and we're done. So when we raise to a power, we multiply. Okay? So on number 4, we have a coefficient here. So I'm raising the 2 to the power of 5. So we actually end up with 2 to the 5th. I'm raising this x squared to the power of 5, so we have x to the 10th. And we have y to the first power, so 5 times 1 is 5, so we get y to the 5th power. Now we need to go clean up the x to the 5th power. Now we know that's 2 times 2 times 2 times 2 times 2. And another way that we can do that in this beautiful tool, and I like to talk about the tool because you'll have the tool on test day for part of the test. So we are going to enter into the tool the base. And then we're going to hit this yx button. Now the y is my base, and that's a 2. And we want it to the 5th power, and we're going to hit equals. And you see that 2 to the 5th power is 32. So our answer is 32, x to the 10th, y to the 5th. We'll do the calculator again so you can see those buttons again. So on this one, we are raising a negative 3 to the power of 3, and we are raising an x squared to the power of 3. So we know that we have negative 3 to the power of 3 times x to the power of 6. So if we use our tool, we can put a 3 in the calculator and hit this plus minus button to make it a negative 3. Then if we come up here to this button, we want to raise it to the power of 3, and we hit equals, and we find that it's negative 27. So our answer is negative 27x to the 6th. It's a great tool. Now on these, I kind of want you to think of a half as a denominator and numerator that are both getting raised to the power. So this 1 is being raised to the power of 3, so 1 times 1 times 1 is 1. And then this 2 is being raised to the power of 3, so that's going to be 2 times 2 is 4 times 2 is 8. Then we are raising the a to the cube, the b to the 4th, and the c to the 5th. So 3 times 3 is a to the 9th. 3 times 4 is b to the 12th. 3 times 5 is c to the 15th, and there you have your answer. So I'm going to break them down a little more so you can see them. I think it's important that you can visualize what's going on. So here I have a negative 2 being raised to the power of 2. So what we really have is negative 2 squared. And then we have a to the 4th times being raised to the power of 2, so it becomes a to the 8th. Then we have b to the 6th being raised to the power of 2, so we have b to the 12th. Okay, so my variables are done. We have a to the 8th, b to the 12th. Now negative 2 times negative 2 is a nice positive 4. And you're done. Okay? On number 8, we have negative 5 to the power of 2. Negative 5 times negative 5, let's just write that down to the power of 2. So negative 5 times negative 5 is 25. I'm going to write that off to the side. Then we have 2 times 3 to get x to the 6th. We have 2 times 4 to get y to the 8th. And there's your answer. Okay, number 9. Okay, now we have something different happening on number 9. We're not only are we going to raise something to the power, but we're also going to end up multiplying. We have two problems going on, this one and that one. So we're going to do the power one first. So, and I'm just going to put my multiplication symbol nice and big there so that you can see it on the dot cam. Here we go. So now we have 3 being raised to the power of 3. So that's x to the power of 9. We have y being raised to the power of 3, y cubed being raised to the power of 3. That's y to the power of 9. All right. Now we've got that part done, and it's being multiplied times x, y squared. Now wait, when we multiply with exponents, we add them. Okay, so and on this x, there's a hidden 1. Everything's to the power of 1. Okay, so that's x to the 9th times x to the 1st is x to the 10th, because we add them together. Y to the 9th times y to the 2nd is y to the 11th, because we add 9 plus 2 to get 11. So we had two things going on. We have the thing we've already learned, and then the new, which was multiplication, and then raising of the power. So we raise to the power first, just like order of operations. We raise to the power, and then we multiply. So here's our multiply between. I just want to make it a little larger so you can see it. Okay, so I am going to raise negative 2 to the power of 2. Negative 2 times negative 2 is a positive 4. I'm raising the power of a to the power of 1 by the power of 2. 2 times 1 is a squared. 2 times 2 for b is b to the 4th. Times, now I got to raise this one to the power of 2 over here. 3 times 3 is 9. A squared times being raised to the power of 2 is a to the 4th. And b to the 1st being raised to the power of 2 is b squared. Now we've done the multiplying because we're raising to the power. Now we are going to multiply these two together. 4 times 9 is 36. And then we have a squared times a to the 4th. We add them together, so we get a to the 6th, because when we multiply with exponents, we add. B to the 4th times b to the 2nd is b to the 6th. And there you go. Very carefully. All right, so then we have this one. So I'm going to raise each one of the powers, and then I'm going to come back and do this final multiplication problem. But exponents come before multiplying. Please excuse my dear Aunt Sally. So we have 6 to the 3rd power. That's 6 times 6 is 36 times 6. So let's do this in here. 6 being raised to the 3rd power equals 216. So 216. And then I have a to the 6th, b to the 3rd. Now I'm going to multiply that times this, but let me just go ahead and raise each of these to the power of 2. So 1 times 1 is 1, 3 times 3 is 9. And then I have a to the 1st, b to the 2nd, c to the 1st being raised to the 2nd power. So that becomes a squared, b squared, c squared, because 2 times 1, 2 times 1, 2 times 1. Okay, Now that I've got that done, I need to multiply these two things together. Now, you have a choice. You can do it mentally using mental math, because I do know that 9 goes into this 24 times, but let's just look at the problem. Let's check it out. So here I have 216 times a fraction, and the fraction is 1/9. So I'm going to put in my 1, I'm going to use my fraction bar and my 9, and I'm going to hit equals, and you get 24. So my result is 24. I have a to the 6th times a to the 2nd. When we multiply, we add, so you get a to the 8th. I have b to the 3rd times b to the 2nd. When we multiply, we add, that's b to the 5th. And then we have a c squared by itself, so there is your final result. Okay? Then I thought it would be good. I think I'll just do 14, because we do need to do the geometric shapes next. So we have 3 being raised to the 4th power. So I'm going to put that in the calculator. 3, and I'm going to use this button, and I'm raising it to the 4th power, and I'm hitting equals, is 81. So I have 81, x to the 3rd being raised to the 4th power is x to the 12th, and y to the 1st being raised to the 4th power is y to the 4th. And in between here, we have a subtraction problem. Now this 7 is being raised to the 2nd power, that's 49. This x to the 5th is being raised to the 2nd power, that's x to the 10th. This y to the 1st is being raised to the 2nd power, so it's y squared, times x squared, y squared. Now, order of operations says I cannot subtract before I multiply. So I'm going to cover this, and I have to multiply a negative 49 times a positive 1 right there, and I get negative 49. X to the 10th times x to the 2nd is x to the 12th. We add them together. Y to the 2nd times y to the 2nd is y to the 4th. In front of this, we had 81 x to the 12th, y to the 4th. Oh, that's awesome. They're like terms. X to the 12th, y to the 4th. X to the 12th, y to the 4th. So now I just need to do 81 minus 49, and I get 32. X to the 12th, y to the 4th. We don't change the exponents when we combine or subtract, add or subtract. Okay, so that was raising to the power, and that comes in handy when we do these next problems, which are our geometric applications. So remember, the perimeter of a rectangle has 2 widths and 2 lengths, and if we do these together, we know that we are going to have to work all the way around the perimeter. So we have 2 of the 12 x's, and we have 2 of the 5x squared. And so when we do perimeter, and that equals our perimeter. Now, just remember, perimeter is 2L plus 2W to equal perimeter, okay? So that's what I did. And so 2 times 12 is 24x. 2 times 5 is 10x squared. I cannot combine these two together, and I'm going to leave it just like that as my perimeter of the rectangle. The perimeter of the triangle here. Oh, and this also has the area. The area of a rectangle, area equals length times width. So that's pretty easy, actually. Length is, we could call either one length or width. So 12x times 5x squared. So length times width would be 12 times 5, which is 60. And x to the 1st times x to the 2nd, we add them together to get x to the 3rd. And there's your answer for the area. All right, and then the next one is the triangle. The perimeter of the triangle is, obviously we're going to add them together. So we have 4a squared b plus 10a squared b plus 3ab. This would be the perimeter of the triangle, and 4a squared b and 10a squared b are like terms, so I can add them together to get 14a squared b plus 3ab cannot add 3ab to 4a squared b, not like terms, and you're done. So that's the perimeter. The area of a triangle, let's just write down the area of a triangle, is half the base times the height. Yeah, base times height. There you go. Okay, so now with that, we know that we have half times the base, which is 3ab, times the height, which is 4a squared b. So when we work this problem, we know that this is going to be 4 times 3. I can multiply in any order I want, to be honest. So 4 times 3 is 12. So 1/2 times 12. A to the first times A to the second is A to the third. B to the first times B to the first is B to the second. Now I just have to multiply by 1/2, which cuts the 12 in half. So we end up with 6a cubed b squared as our area of the triangle. Then we have the same type of problem, so I'm going to move away from this one. Just remember that each one of these sides is the same measure when you do perimeter. So I think maybe that would be kind of fun to do. Let's do that. Perimeter equals 3 times, because there's 3 that are 5m cubed n to the 4th. Okay, so that ends up being 15 m cubed n to the 4th. And there's your answer for your perimeter of this guy. Now to do the area, it's the same as this one up here, except we are doing this base, which is half of that. So we would have to half the base. So on our area, we have to first find half the base. So half of the base, and the base is 5m cubed n to the 4th, times the height, and the height right here is 4m n to the 5th. So now you can see where you can use all of the skills that we've learned so far. 4 times 5 is 20. I like to do these first because I can cut it in half at the end. And m to the 3rd times m to the 4th first is m to the 4th. N to the 4th times n to the 5th is n to the 9th. And we are going to multiply that times 1/2, so the 20 becomes a 10 m to the 4th n to the 9th. And you're done. And there is your area of that triangle. Then we have the area of this shape here. So here we go. The area equals 1/2 the base 1 plus the base 2 added together times the height. So because these are parallel sides. So here we go. We have a base, and there's the height. So I'm just going to plug in. And again, I like to use that half whenever it's convenient to do. So base 1 is 7x squared y plus base 2, which is 4x squared y. Oh, those are like terms. We can add those two together. And the height is 2xy, but we're multiplying that. So we're good with that. So when I add these two together, I end up getting 1/2 times 11x squared y, keep the same exponential powers because they are like terms, times 2xy. When I multiply these two together, I get 22x to the 3rd, y to the 2nd, and we're going to multiply this times 1/2. So we end up with 11x to the 3rd, y to the 2nd. And then our last one is a circle. And oops, let me just make sure you can see that okay. The last one is a circle, and we're doing the area of the circle. The area of a circle is pi r squared. There. Our radius is right there. We're going to leave pi, and we're going to just play with the symbol of pi. So we have area equals pi times 3xy cubed, and it's being raised to the power of 2. So I'm going to raise this to the power of 2. That's my first task. So I end up with area equals pi, and 3 to the power of 2 is a 9, and x to the first to the power of 2 is x squared. Y to the 3rd being raised to the power of 2 is y to the 6th, because we're multiplying when we raise to the power. Now this is your answer, but we like to write it in proper form. The proper form for this, and I want you to make sure you do that, and that is 9 pi x squared y 6. That's how we write that, 9 pi. I got kind of a little messy, but that's good. Okay, so there's power in the power. So maybe our passcode needs to be the power rule. All right? And good job today, guys. Hopefully it goes smooth for you.